Hey guys, this is Coach Brian going over the 11.1 notes with you. They are the first lesson in our two-dimensional shapes unit, and they are all about perimeter, area, and circumference of various shapes. So I think the first thing I want to do is for each shape, we'll go over what the perimeter is, and we'll go over what the area is, and by that I mean like what formula to use. And then we'll actually work some examples with each. So starting off with a square. All right, you know the perimeter is the distance around all sides. All right, around all sides. And so we have to have a formula or an equation or something that ends up adding all of the sides. So for a square, we can actually use 4s, where s is our side, because all the sides are the same. So 4 times the side is going to be the same as saying side 1 plus side 2 plus side 3 plus side 4. So that's the perimeter of a square. Excuse me. Now, a similar shape is a rectangle, but you know that where a square has 4 congruent sides, a rectangle has opposite pairs of congruent sides. All right, opposite pairs. So that means my widths are the same and my lengths are the same, but not all 4 sides are the same. So my formula for it would be 2 times the length plus 2 times the width. So 2 widths, 2 lengths, add them together, you get the full distance around. For all of these other shapes, all right, for these that this box right here goes by, for the perimeter of all of these, you are going to add all of the sides. There's really not any other way around it than to add all of the sides. So that will give you the perimeter of those shapes. And then lastly, looking at a circle, the perimeter of a circle is called the circumference. And so that would be 1 trip around the circle, if you will. And we use circumference equals 2 times pi times the radius. So remember, the radius is the distance from the center of the circle to the edge of the circle. So it's half of the diameter. Now, before we get into any more problems, let's go back up to the top and let's talk about the formulas for area. All right, so if you remember, the area is the total space. I don't want to use in, I want to use within a shape. Total space within a shape. All right, so it's like inside the boundaries of this shape, how much space is that? So for a square, it's going to be a side times another side. And since they're all the same, we can just say side squared, because it's the same thing as saying side times side. And they're all the same, so just pick 2 of them and multiply them together. For a rectangle, the area is going to be 1 of the lengths times 1 of the widths. And now here's, on these more kind of unique shapes, they're a little bit different. So one thing I want you to look at for this parallelogram is if I took this section of this parallelogram and I just moved it right here, do you see how that would make a rectangle? So the parallelogram area is length times width, just like a rectangle. But a maybe easier way to remember it for a parallelogram is the base times the height. That way you know to use this number, like 4 right here, the height of the shape. instead of one of the diagonals, which we'll talk about how to find in just a second. All right, the next shape, a triangle, is like our drawing shows here. It's like half of a rectangle, right? It's like if you just took one and sliced it right down the middle, you've got like half of a rectangle. So you would use the base times the height, but then you'd cut it in half. And then our last one is a trapezoid. And for a trapezoid, this one is a similar formula, but you're gonna actually use the sum, okay, of base 1 plus base 2. You're gonna divide that by 2 and then multiply that by the height. So again, the height would be this number, like how high is the shape at its tallest point. And then lastly, for a circle, to find the area, it is pi times radius squared. Pi times radius squared. All right, so let's actually work some examples now. And for some of these, I'm gonna move kind of quick because they're simpler, and then others I'll spend a little more time on. First off, for this square, all right, you can see that the side is 11. And since it's a square, that means all the sides are 11. So for the perimeter, I would just do 4 times 11 because there's 4 11 sides, and that would give me 44. And it's also important to make sure you put the unit. So for this one, it's feet. Now for the area equals side squared, so that would be 11 squared, which is the same as 11 times 11, which is 121. And when you're doing area, your units will be squared. So this is 121 square feet. Now moving on to the rectangle. The rectangle has a length or height of 6. It has a width or a base of 11. So for the perimeter, we would say 2 times 6 plus 2 times 11, and that would be 12 plus 22, which is 34. And again, this is feet. For our area, it's length times width, so it would be 6 times 11, which is 66 square feet. So those are kind of the common ones you've been using a really long time. These others can be a little more tricky, mostly because they involve diagonal lines, but they also involve right triangles, which means you can use Pythagorean theorem to find your missing sides. So this first one is probably going to be the one that takes the most time. Let me just start fresh with it. I know some of y'all are going to be mad I'm erasing in my notes, but that's okay. Let's start fully fresh with this shape. So the perimeter, for the perimeter, I need to add all the sides. Well, if this top base is 22, this bottom base is also 22. So that's helpful because I have 2 sides, but what I'm missing is this diagonal. It's not 4, that's my height, but it's not the length of this diagonal line. So what I need to do is to just consider this triangular end and calculate the missing hypotenuse. So to do this, you're going to have to recognize that this is a special triangle. It is a 30, 60, 90. 30, 60, 90. And so when you have a 30, 60, 90, the sides have ratios. So all we know right here is the short side. How do I know it's the short side? Because it's across from 30, which is the smallest angle. So I know the short side is 4, and the ratios for a 30, 60, 90 tell me that the hypotenuse right here is double the short side, and the medium side, not that we need it right now, is the short side times the square root of 3. So ultimately, what I really needed to take away from this is that the hypotenuse is 8, and it means that the ends of both of these, both ends of this parallelogram are 8. And so to add up all the sides, I would do 22 plus 22 plus 8 plus 8, which is 60 centimeters. That's my perimeter. Now to find the area, it's much easier. It's base times height. 22 times 4, which is 88 square centimeters. All right. For this triangle, they have already given us all 3 sides, which is very helpful. But if you didn't have that, you could use the Pythagorean theorem to find it. Now, we're going to do the perimeter first. So all the sides, 21 plus 19 plus 22. And that is 21, 19 is 40, 62. 62 kilometers is my perimeter. For my area, I'm going to take the base of this triangle, which is 21, multiply it by the height, which is 19, and divide that by 2. So 21 times 19 is 399. And half of that, made an error, hold 1 second, divided by 2. Half of that is 199.5, and that would be kilometers squared. And then our trapezoid. For the trapezoid, the perimeter is going to be all the sides. Well, guess what? This is an isosceles trapezoid. So I know the legs are congruent, but I don't know what they are. So similar to our problem above, we're going to need to use Pythagorean theorem. So there is a way we can figure this out, okay? If I, from this corner, drew a line straight down, perpendicular, and I drew a line over here straight down, you would see that these 11s, 11, 11, they match. But this total side is 15, which means it's got a little bit left over here and a little bit left over here. And so if 11 of it is in between these two imaginary lines that I just drew, that means 4 of it is split over here and over here. Now that gives me 2, 11, 2, which all adds up to 15. So I do have, even though at first it didn't look like it, I do have all the sides of this triangle. It's a 2 and a 9, and I'm looking for the hypotenuse, and it's a right triangle. So I'm going to use 9 squared plus 2 squared, and that will give me my hypotenuse, and that's 81 plus 4, going to equal c squared. And how do I get rid of a power? I use a root. So the square root of 85 is going to be my hypotenuse. And if you tried to break that down and simplify it, there's no crossouts or kickouts that can happen. So we're going to leave it. Whoa, what just happened? We're going to leave it as square root of 85. Sorry, my iPad's kind of messing up. Now, that is just what C is, okay? That's not my area or my perimeter. That's just that side. So that means this is square root of 85. This is square root of 85. And then both of these sides are 11 and 15. So I would add those up for the perimeter. I'm going to do 11 plus 15 plus square root of 85 plus square root of 85. I can add these together because they're like terms. That's going to give me 26. And then I have 1, 2 times the square root of 85. And I might be wrong on that simplification, but forgive me if I am. All right, that's my perimeter. Now for my area, it's going to be the two bases added together divided by 2 times the height. So base 1 is 11, base 2 is 15. I'm going to divide that by 2 and multiply it by the height, which is 9. So 11 plus 15 is 26. 26 divided by 2 is 13. 13 times 9 is 117. So my area is 117, and that is in centimeters squared. Also, my perimeter is in centimeters. All right, last one on the front of these notes is the circle. So for the circle, starting with the circumference, I want to try to find the distance around 1 time. So I would do 2 times pi times the radius, which we already said over here, is 2. So we've been leaving things in terms of pi a lot this year, which means I'm just going to multiply these two numbers and then multiply them times pi. And I'm going to leave that as my answer. And that's feet, because that's the unit I was given. Area is similar. It's going to be pi times the radius, which is 2, squared. And 2 times 2, 2 times itself, happens to be 4. So the area of this circle is also 4 pi, but it's feet squared. 4 feet squared. All right, so that's part 1 of these notes. I will upload a video working on the second page